Hi, I would like to prove that the natural log of x equals I times the arc cosine of 1 plus x squared over 2x, where I equals the square root of minus 1. So using a complex number to bridge between the natural log and arc cosine. Okay, so we start off then by saying the arc cosine of x equals minus I times the natural log of x plus root x squared minus 1. And my last video was actually proving that, starting off with e to the ix equals cos x plus I sine x, and then the derivative of that for the term of cos x. So that was my starting point. Okay, so if I do another substitution and say u equals x plus x squared minus 1, then u minus x equals the square root of x squared minus 1. Square both sides, u squared minus 2ux plus x squared equals x squared minus 1. Take away x squared from both sides, you've got u squared minus 2ux equals minus 1. Multiply both sides by minus 1 says that 2ux minus u squared equals 1. So 2ux equals 1 plus u squared, x equals 1 plus u squared over 2u. Okay, so this x equals 1 plus u squared over 2u, if you put that back in the top equation, that means in the arccos of x, which is the arccos of 1 plus u squared over 2u, go back to the top, that's minus I times the natural log of x squared plus root x squared minus 1. And of course the x plus root x squared minus 1 is the u, which means then that the arccos of 1 plus u squared over 2u, that's equal to minus I times the natural log of u. So if you just change the names then, so obviously if arccos 1 plus u squared over 2u is equal to minus I times natural log of u, it also must mean then that the natural log of x equals I times the arc cosine of 1 plus x squared over 2x. Okay, hope you enjoyed that, and thanks for watching.